So now that we can describe the actual parameters of the distribution based on the central limit theorem, the reason we want to do this is just like we did with our proportion, we want to calculate normal probabilities, right? And central limit theorem allows this distribution to be normal. But there are other conditions that must be met, just like with proportions, that we have to check and state before we actually do this. So the other conditions, there are three conditions that we're going to check here. And the first one is what we call the random condition. And it says that the sample drawn must be randomly selected. And the purpose of this is because we want to make sure we have what's called an unbiased estimator. And in order for it to be unbiased, the sample has to be randomly chosen. Most of the time, this will be stated. This will be stated here. But if it's not stated, we can assume it. And by assumption, I mean, we're talking if you select some people, we can assume that the people don't know each other, so they're randomly chosen. Those type of things. So this is what we call, we need this for it because we need the sample to be unbiased, the estimator to be unbiased. The 10% condition, just like we talked about with proportions, in 10% condition, proportions showed that it was independent. Well, for a mean, and a mean is a proportion is a special type of mean. But for the mean, the 10% condition allows the standard error to be true, which is this right here. It allows us to use this right here, the standard error. And remember, that says that we sample no more than 10% of the population. And we state that by saying, surely, whatever we're talking about is less than 10% of the population. And then our third thing, the other condition we need to make sure we make, is the large enough condition. And for us, the large enough condition, remember when we did it for proportions, it was the success failure condition had to be greater than or equal to 10. Well, for a mean, the large enough conditions just based on the central limit theorem. So either n is going to be greater than or equal to 30, or the population you're pulling from is already normal. So if we can meet all those conditions, we can actually find normal probabilities. And so that's what we're going to do here. So suppose the number of texts sent during a typical day by the population of students at a large high school follows a right-skewed distribution with the mean of 45 and a standard deviation of 35. How likely is it that a random sample of 100 students will average at least 50 texts per day? So when I do a problem like this, the first thing I want to do is identify the sample size. And my sample size here is n is equal to 100. Now, what I'm going to do next is this. I'm going to go through like we did proportions. 100 is significant because, remember, we can use central limit theorem. And I'm going to go through like I did with the proportion. The first thing I'm going to do is I'm going to define the parameter. So I'm going to define the parameter here. And what am I actually talking about, or what is the population focusing on? Well, it's the number of texts sent during a typical day by students. So we define the parameter, and the parameter is the mean here, mu. Mu is equal to the average, the true average, or the true mean number of texts sent by students at the school, at a large high school. And we know that mu itself is equal to, they define the mean as 45. And they also gave us our standard deviation as being 35. So these are the parameters we're looking at. Second thing we did was we checked conditions. So we're going to check our conditions. Remember, we have these three conditions to check. The first condition is the random condition. And notice that in this part right here, it literally says that how likely is it that a random sample, so the random condition is met. And here we're going to say is stated. It's stated in the actual problem. Second condition we're going to check is the 10% rule. And the 10% rule says, surely 100 students at a large high school is less than 10% of all students at this school. So there goes basically our independent statement. And then the last thing we're going to do is we're going to check we want a normality statement or the large enough statement here. And remember, we're doing the large enough condition because we want to show something is normal. We want to do a normal curve here. So large enough, we know that our n is greater than or equal to 30. So by the central limit theorem, x bar follows an approximately normal distribution. Once I have these conditions checked, the next thing we said when we did the proportion, we're going to do the same thing basically with this, is we're going to state the parameters. So the third step is to state our parameters. Third step is state the parameters. And so we're going to say this, x bar follows a normal distribution with the mean equal to the mean of the population, which in this case was 45, and a standard error, or a standard deviation of 35, divided by the square root of the sample size, which is 100. And we can go and clean that value of 35 over 100 up. Square root of 100, so square root of 100 is 10, so this will be 35 divided by 10, which is 3.5. And then our fourth and final step is to find that normal probability. So we're going to find the probability. And the problem said to find what is the probability that they average at least 50 texts per day. So at least 50 texts per day, we're going to write this statement as a probability x greater than or equal to, or just greater than or equal to 50 here. We're going to draw a normal curve. And on this normal curve, I'm going to put the mean, which sits at 45. And I'm asking about the value 50, which sits on the right side of the mean. And I'm going to be greater than or equal to that, so I'm this way here. And so all we're going to do is we're going to go to our calculators, our inspires. And remember, when we want to do normal curves, we're going to do normal CDF. And remember, normal CDF, to get there, you're going to go to add a calculator, number 6, statistics, number 5, distributions, number 2, normal CDF. So 652. And we want to start off with our lower bound. Where our lower bound is where our shading starts, and our shading starts right here at 50. Then we want to go to our upper bound. Well, the upper bound is going on forever in this direction. Remember, we need to put a number back there, so we put a bunch of 9s. The mean of the distribution is 45, and the standard deviation we got up here a second ago, the new standard deviation here. That's the only thing that's really different. It's the new standard deviation, which is the standard error is 3.5. So when I calculate this value, I get this probability is equal to 0.077. So there is a 7.7% chance of getting a sample of at least 50 or more. And it really says that if the average is 45, and I look at 100 students, and I got an average of 50, the only time I get that is about 7.7% of the time.